In July 2025, Toyota released a technical service bulletin for the brand new Land Cruiser and 4Runner. The bulletin addressed brake squeal on vehicles costing over $70,000. Their prescribed fix was not new pads or rotors, but a $20 kit of shims and grease applied to 10 specific locations on the brake assembly. That decision reveals a completely different philosophy about brake noise, one that Japanese manufacturers have been refining for decades. Brake squeal isn't rare. It's one of the most common reasons drivers return to the dealership or call their local shop, even on vehicles with brand new brake systems. In a recent industry survey, more than 40% of service advisors ranked brake noise among their top 3 customer complaints. Some automakers have reported that, for certain models, brake squeal is the #1 reason for warranty callbacks in the first year of ownership. The sound itself, sharp, high-pitched, impossible to ignore, can start with just a light touch of the pedal, sometimes right after a rainy day or a car wash, sometimes for no obvious reason at all. Owners often assume it means something is wrong or worn out, especially when the car is new or expensive. But the reality is more complicated. Brake noise crosses every price bracket, from compact sedans to luxury SUVs. It frustrates drivers who expect silence, and it pressures service departments to find a fix, even when the brakes are working exactly as designed. The scale of the issue is measured in thousands of complaints every month, not just in the United States, but around the world. For many, the expectation is that noise means a part needs to be replaced. Yet as the data shows, most of these cases have nothing to do with worn-out hardware. A squealing brake can sound expensive, and for many owners, it is. The moment that high-pitched noise appears, the usual advice at a dealership or chain repair shop is simple. Replace the pads, maybe the rotors, and sometimes the hardware, no matter how new or unworn those parts might be. The bill for this approach ranges widely. At a typical shop in the US, a brake noise complaint often leads to a quote between $150 and $900, depending on the vehicle and the shop's policies. For luxury SUVs and trucks, the upper end can climb even higher. Compare that to the cost of a specialized anti-squeal kit, like the ones used by Japanese mechanics and now recommended by Toyota for its newest models. These kits, which include shims and high-temperature grease, usually cost between $15 and $50. The difference is stark. For the price of a single brake job at a dealership, an owner could buy enough do-it-yourself kits to treat every car on their block. This gap is not just about saving money. It is about the frustration of paying for new parts when the real problem is not wear, but vibration. For drivers, that means the promise of a fix that targets the noise directly, without unnecessary replacement, and without the sticker shock that so often follows a routine visit for a simple sound. Inside the service bay, engineers do not just listen for squeal, they measure it. The Society of Automotive Engineers defines brake squeal as a sustained, high-pitched noise between 1 and 17 kilohertz, reaching at least 70 decibels. The science behind that sound points to a phenomenon called mode coupling. When the brake pad and rotor come into contact, they can vibrate together in a way that amplifies certain frequencies. This is not a matter of parts wearing thin. Even a brand new pad, thick and perfectly within specification, can trigger the same instability. The culprit is dynamic. Small differences in surface roughness, humidity, or even the way the caliper flexes under pressure can tip the system into a state where energy feeds back and forth between the pad and rotor. That is why the volume of the squeal can be so high, even if the vibration itself is too tiny to see. Research published by SAE in leading tribology journals confirms that the thickness of the pad has little to no effect on whether squeal occurs. Instead, it is the interaction, the way the components vibrate together, that creates the noise. This view reframes brake squeal as a vibration problem, not a wear problem, and opens the door to solutions that target the instability itself. Japanese brake suppliers have taken a different approach to noise, one built on decades of refinement and a philosophy known as Kaizen, or continuous improvement. Among these companies, Akebono stands out with a global presence and a reputation for precision. Supplying roughly half of all original equipment brake pads in Japan, Akabono's influence reaches well beyond Toyota, shaping standards across the industry. Their engineers do not treat Squeal as an afterthought or a nuisance to be silenced by replacement. Instead, they design each pad with a layered system, carefully tuned shims, high-temperature grease, and detailed installation guides. Edvix and Dixcel, two other leading Japanese suppliers, follow similar protocols. Both provide step-by-step instructions for applying anti-squeal grease and fitting multi-layer shims, even on brand new pads. Instead of defaulting to new hardware, Japanese dealerships rely on a 6-part checklist that begins with cleaning, lubricating, and reassembling the existing brakes using these specialized kits. The result is a methodical, repeatable process that targets vibration at its source, not just the symptoms. This approach has shaped the way brake noise is managed across Japan's automotive sector, setting a standard that prioritizes precision and cost-effectiveness over unnecessary replacement. Technicians in Japan begin by inspecting the pad edges for sharp corners. The first step is to chamfer each pad at a 45-degree angle, cutting back about 1/8 of an inch. This simple change in geometry disrupts the way vibrations build at the leading and trailing edges, reducing the risk of high-frequency squeal. A 2019 AIP study found that 96.7% of tested cases showed a measurable drop in noise after proper chamfering. Next, a thin layer of anti-squeal compound is applied to the pad backing plate. This specialized paste acts as a cushion, absorbing small movements that could otherwise turn into audible squeal. The third step focuses on shims, thin, multi-layered plates that sit between the pad and the caliper piston. Shims are engineered to interrupt the transfer of vibration from the pad to the rest of the brake assembly. Even a millimeter of the right material can mean the difference between silence and a persistent squeal. These first 3 steps, chamfer, compound, and shims, create a foundation for controlling vibration before any lubricant or cleaning is applied. Step 4 calls for resurfacing the pad face. Technicians use a sanding block or an orbital sander with 120 to 150 grit abrasive to remove glazing and restore a fresh, even texture. This grit range is fine enough to avoid gouging, yet coarse enough to break up hardened deposits that can trigger vibration. Once the pad surface is uniform, attention turns to the rotor. Any loose rust, dust, or debris is carefully cleaned away. Technicians use brake cleaner or a dry cloth, taking care never to contaminate the friction surfaces. Only after both pad and rotor are spotless does the lubrication begin. Here, the choice of grease is precise. On the pad ears and contact points, technicians often use a high-temperature PTFE-based lubricant or a specialized rubber grease like Shinitsu. For the shim and pad backing plate, a thin layer of Molykote AS880N or M77 is applied, both engineered to withstand extreme heat and pressure without breaking down. Each compound is chosen for its stability and its ability to dampen micro-movements. With all surfaces prepared and lubricated, the hardware is reassembled, setting the stage for the final bedding process. Bedding the brakes is the final step before returning a car to the road. Technicians follow a controlled sequence, like the Advix 30-30-30 protocol, which is 30 stops from 30 miles per hour, spaced to avoid overheating. This process transfers a thin, even layer of pad material onto the rotor, stabilizing friction and reducing the risk of future squeal. Some shops use the 5 stops from 40 method for similar results. Skipping this step can leave brakes noisy, even after careful assembly. There are limits to what bedding and shims can solve. If pad thickness falls below 3 millimeters, replacement is non-negotiable. That's the industry's safety threshold. Any sign of metal on metal contact, bright scoring on the rotor, or visible steel backing means immediate failure. No amount of grease or shims can fix worn-out hardware. For drivers and technicians, the message is clear. Precision matters, but so does knowing when to stop. The Japanese method delivers quiet brakes, but only within the boundaries of safe, serviceable parts. Today, millions still pay hundreds of dollars for brake noise fixes that could cost less than a tank of gas. As repair prices climb, precision thinking, not just parts, matters more than ever. Sometimes, the smartest solution is also the simplest. What do you think? Drop your thoughts below.